in this problem we have to reverse a given linked list. So user will give us a linked list and we have to reverse a particular given linked list. So let us consider a linked list that is 1, 2, 3, 4 and it is pointing to null. So let us consider that this is our given linked list. So we need to reverse our linked list. So the reverse linked list will be 1, 2 will point to 3 and 3 and 4 and 1 will point to null. So this is our reversed linked list. So how we gonna do this? The main logic in reversing a linked list here is, first of all, we are not going to create extra space. Some people will create a new linked list. After that they will start pointing the given data with the previous data. So we are not gonna do that. We are not gonna use no extra space. Right here we are not creating any extra space, but we are going to reverse the given linked list. How we gonna do this? The logic here is reversing a linked list is a 4-step process. First step will be to understand the logic. Let us consider a linked list, that is this is our linked list and there are some elements here and there are some elements on the left and the right. So let us consider that this is our previous and this is our current and this is our next. So the first step will be in reversing a linked list. The linking direction is like this right now. So we need to reverse the link. We need to reverse each and every link. So here previous is pointing to current and current is pointing to next. We want that next will point to current and current will point to reverse previous. So this is how we are going to do the reversing of the linked list. So what are the steps? Reversing a linked list is a 4-step process. The first step here will be, first of all, we need to point next is equals to current dot next. So here we need to point next is equals to current dot next. After the second step will be current next will point to our previous. So instead of pointing, current is pointing to next now. Instead of pointing to next, we are going to point this connection to previous. And the third step will be, we are going to change the current previous value. So previous is equal to current. So here this previous will change into current and this will become our next. So the fourth step will be my current is equals to next. So first step will be, instead of pointing to like the next direction, our next will point to current. After that current will point to previous and we are going to change the previous, current and next values. These are the 4 steps we are going to follow to reverse a given linked list. So let me draw it again. This looks kind of messy. Like this is our previous, right? After this is our current and this is our next and this is the direction of pointing. Okay, so first of all, what I am going to do is next is pointing to its corresponding next element. Instead of pointing to corresponding next element, I am going to point next to current and I am going to break this connection. After that, the current will point to previous and I am going to break this connection. After changing the direction, what I am going to do, I am going to change the value of next. So next will become current and my current will become previous and previous will get shifted to the next element and a similar process will get continued on the next element also. So what is the pseudocode here? The pseudocode will be, first of all, we are going to create our function public void type function reverse. Reverse is the name of my function. After that, here first of all I am going to create node previous. Node previous, initially let us consider that this is my linked list. 1, 2, 3, 4 and 4 is pointing to null. So initially my previous will be null. Previous is equals to null and this is my current and this is my next. So initially my previous is equals to null. After that, my current, node current is equals to, you can see that here this is my head and this is my tail. So in the reversing process, the tail will become my head. So instead of after reversing, changing the value of head and tail, we can, in the first step also we can change the value of tail. So here my tail will become tail is equals to head. So here I'm storing the value of current, I'm storing the value of head in current. After node next, that's all. I'm not gonna like do anything here. I'm just pointing, I'm just creating node next. After that, I'm running a loop while my current is not equals to null. In this, first of all, what I'm going to do, the first step, that is next is equals to current dot next. After that, my current dot next, the second step will be current dot next is equals to my previous. After that, my current is equals to next. After that, I'm going to change the value of head. Head is equals to previous. That's all. So this is how I'm going to change my linked list in reverse order. Now let us code this thing. So here I'm going to create a function for reversing my linked list. So first of all, my function public void reverse LL. After that, what I'm going to do here, the first thing will be creating my node previous. Previous is equals to null. After that, node current is equals to tail is equals to head. After that, here I'm going to create my node next. First of all, at the declaration step, I'm not initializing the value of next, because in the first step what I'm doing, I'm initializing the value of next. Next is equals to current dot next. So here, while my current is not equals to null, the first step here, the first step one will be next is equals to current dot next. After that, I'm changing my current value. This is my step 2. I'm changing my current value. Current dot next is equals to my previous value. My previous, after that step, I'm changing my previous value. Previous is equals to my current element. Step 4 will be, I am changing my next value. First of all, here step 1 is next initialization. Next initialization, and the second step will be changing current. After initializing next node, we are changing the current value. So I am changing my current value. After the third step will be changing my previous value, and the fourth step will be changing my next value. So here I am changing my next value. Current is equals to next. That's all. And after completing this whole loop, what I am going to do, I am going to change the head value. Head is equals to my previous. That's all. Now here, first of all, I am adding all the elements and I am printing the elements here. Now let me reverse the given linked list LL dot reverse LL, and after reversing, I am printing again LL dot print. That's all. Now let me save and run. So here you can see that first of all, before reversing, this is my linked list, and after reversing, this is what my linked list become. All the values have pointing to its previous elements. So this is how the reversing process works. So what are the things we are doing here? We are declaring 3 pointers, or you can say 3 node variables. That is, first of all, my previous, and initially the previous will be null. After my current will point to my head. After the next value, and initially I'm not gonna declare the value of next. After that, I'm running a loop while my current is not equals to null. While my current is not equals to null, what I'm doing, 4-step process. First step is initialize next value. So next value will become next is equals to current dot next, and the second step will be current dot next is equals to previous. So what I'm going to do, I'm going to change the value of, after initializing next, I'm going to change the current value, and the third step will be changing the previous value. After changing previous value, finally my fourth step, that is change the current value. So current will become next, and this process will continue until my current value touches null value. This is how I'm going to like run my while loop, and after running all the things, what I'm doing, I'm changing the next value by I'm changing the head value by previous. So this is how the reversing process will work in our linked list. Now in this question, this is a like important question. You can find this question in LeetCode. You can find this question in LeetCode, HackerRank, and all CodeChef, HackerRank, and many more competitive coding platform. And this question is asked in many interviews. So this is kind of a important question. So what the question is asking us, first of all, we need to find the nth node from the end, and after finding, we need to remove that nth node. So how we gonna do this? Let us take an example that this is my list 1, 2, 3, 4, 5, and 5 is pointing to null. So here let us consider that I need to remove the third node from the last. So this is my first index, second index, third index. So I need to remove this node. We already know that to remove a particular node, we need to just change the next value. So we need to change its previous connection to its next connection. So instead of pointing to 3, I can directly point to 4, and this particular node will get automatically deleted by my Java collection framework. So we'll talk about what is Java collection framework and how we can like directly implement arrays, linked list, array list, and all hash map, hash sets, and all those kind of things when we talk about Java collection framework. So up to now, you have to understand that when I directly point my 2 next to directly 4, then my 3 will get automatically deleted by my garbage collector or Java collection framework. So this is how I'm going to delete my nth node from the end. But the catch here is how I'm going to calculate. I can, you know that in linked list we can traverse in the forward direction. I can traverse like this, but I can't traverse in this direction. So how I am going to calculate like from the last, how I can calculate? We can't go in the previous direction in singly linked list, right? So how I'm gonna do that? The logic here is, some people think that we need to create a new linked list and we need to reverse all the nodes, and by reversing we can remove the like nth linked list, and again we need to reverse and we'll get the final linked list. Here the catch is we are not gonna create extra node or extra space, extra nodes or extra space. We are going to do this question in the given space. Whatever the linked list is given, we are going to do that particular question in the same space. We are not gonna create any extra space. So the logic here is, let us consider this is my n size list, n size linked list. So the logic, we need to understand the logic here. So the logic here is, what question is asking us? We need to remove the nth node from the starting? No, from the end. So user will give us the indexes from end, and we need to calculate the index, the node from the end, and by like knowing the node, we can like directly delete the node. But the problem is how we can calculate from the end. So I already know that I can like traverse my linked list from the starting. So I can traverse from the start, but I can't traverse from the end. So if I can able to find a relation between the starting and the ending indexes, then I can do some like thing here. Then I can solve this problem. So first thing is find a relation between the starting indexes and the ending indexes. So here you can see that let me redraw my linked list here. 1, 2, 3, 4, 5, and it is pointing to null. So this is my from the end, this is my index 1, index 2, index 3, index 4, index 5, and from this end, from the starting, this is my index 1, 2, 3, 4, 5. So can you observe one thing here? The size of the linked list is here n is equals to 5. So n is equals to 5. Here my size is 5. So I need to find, this is my middle node. Okay. So suppose let us consider that the user has given me this particular node. So here from the starting the value is 4 and from the ending the value is 2. so the values are not same here. So what is the logic? Can I write one thing here, that is my nth node from the end is equals to my size minus the given nth node from end plus 1. This is my nth index or nth node from start. So this is the relation. This is the relation between the starting and the ending index. So what is the relation? Suppose the user has given me 2 from the end. So here 2 is equals to, what is the size of the linked list? The linked list size is 5. So 5 minus 2 plus 1, that is 3 plus 1 is equals to 4. So from 2 from end is equals to 4 from start. We already know that the from starting, what is the index here? The index is 4, and from ending, what is the index here? 2. So this is the formula. What is the formula? Nth node from the end is equals to my size of the linked list minus nth node from the end plus 1 is the index from the beginning. So by just knowing this formula, you can easily calculate the nth node from the starting, and we already know how to remove a linked list from the given nth node. So what we are going to do here, let me write the pseudocode here. So my public static void type function find nth and remove it. This is my function. So here the user will give me index, nth index, let us say idx from the end. This is my given index. Here what I am going to do, I am going to create a variable from my starting idx. Start idx is equals to my size. I already know that how to calculate my size of the linked list. So size minus idx plus 1. After finding size, after finding the index from the starting index, what I am going to do, I am going to create a temporary variable node temp1 is equals to head. After that, node temp2 is equals to head dot next, and I am going to create a counter variable. So I am going to run my loop until I hit my this particular given index from the beginning. So I am going to create int c is equals to 0. After that, loop while our c should be less than a starting index. What I am going to do here, t1 is equals to t1 dot next. After that, t2 is equals to t2 dot next, and I am going to increment c++. Here, after running my while loop, when I hit my this condition, when the this condition will become false, what I am going to do, t1 dot next is equals to t2 dot next. After that, basically return from the program. That's all. So this is how I am going to remove the nth node from my given linked list. So here let me create my function remove nth node from the end. So first of all, I am going to create my function public void type function void remove nth from end. So here I am going to pass two things, that is end index idx end index. After that, my size int size of my linked list. I am going to pass two parameters. After that, here first of all let me check that if head is equals to null, if my linked list is itself empty, then basically return. That's all, return. There is no nothing, what you can say, there is no element in my linked list. Then how you can remove any element if there is no element at all? So basically return. Else what are you going to do, int start index start idx is equals to size minus end idx end index plus 1. That's all. I am going to create two nodes, node temp1 is equals to head. After that, node temp2 is equals to head dot next, and I am going to create a counter variable int c is equals to 0 to keep a track of my iterations. While my c is less than start index. In this, what I'm going to do, temp1 is equals to temp1 dot next. After that, temp2 is equals to temp2 dot next, and I'm going to increment I plus C plus plus. After that, here what I'm going to do, I'm like, instead of pointing, so when I hit this condition, when this condition will become false, the C will be less than my starting index, right? Let us consider that this is my starting index. So this starting index is pointing to temporary 2, and the T1 will points to my C value, right? So here what I'm going to do here, so what temp1 dot next, instead of pointing T1, next will point to T2, right? So instead of pointing to T2, I am directly pointing to the next node of the corresponding T2 element, right? Is equals to temp2 dot next. These single step will remove the nth node. These step will remove my nth node. After that, I'm just returning from my program, return, that's all. So here, first of all, I'm printing my array list, After that, here, instead of calling reverse, I'm calling remove nth node. Here, I'm passing my, what is the, let us say, I want to delete. First of all, let me print my list. Let me see what is the list I have here. So save and run. So this is the list I am having. Suppose if I want to delete the fourth element, that is from the beginning my second index, from the ending my second index. So here I am calling my function ll dot remove from the last, that is ending, and here I am giving 2. And what is the size of my linked list? 1, 2, 3, 4, 5, 6. So 6 is my size of the linked list. So give here 6. That's all. So delete this, and after removing the nth element, I am printing again my list. So let me save and run. Here you can see that first of all, I am printing my linked list 1, 0, 2, 3, 4, 5, and from the third index I am removing the third index here. So here what is the third index? Here from the ending, what is the third index? Third index is 3. So I am removing 3, and after removing I am printing again my remaining linked list. You can see that when I print the linked list again in line 163, when I print the linked list again, 3 got removed here. You can see that there is no 3 in the variable. So this is how I am going to delete the nth element from the ending without creating any extra space in my given program. Now let us talk about how we can detect a particular cycle, or how we can detect a cycle in our linked list. Before that, let us talk about what is cycle. So let us consider that this is my linked list. So up to now we have studied about a linked list is like will have next, and next will be like this. So this will point to null. So this is known as my single linked list, which is having some data and which is having some next. Now what is the meaning of cycle in my linked list? So here let us consider an example that this is my 1, 2, 3, 4, and it is pointing to null. So here let us consider example 1, 2, 3, 4, and 4 instead of pointing to null, it is pointing to 5, and 5 is pointing to 6, and 6 is pointing to again 3. So this thing is known as a cycle in my linked list, or a loop in my linked list. So what is the problem? If there is a loop in my linked list, then what is the problem we'll get? What are the trouble we'll have in our program? The thing is, when we have a cycle in my linked list, when when we used to traverse in my linked list, I used to run my loop while temp is not equals to null. So what I used to do, I used to write while my temporary variable is not equals to null. So by doing these step, I used to traverse in my linked list. So here you can see that in the cycle detection, there is no null at all. So this loop will continue, and this infinite looping will occur, and my code will get crashed. So to avoid this problem, the problem is infinite looping. So when I traverse in my linked list, or when I perform some operations in my linked list based on the value of null, there will be no null in my linked list. So that thing will cause a problem in my linked list. So to avoid this problem, we need to detect a cycle. If there is a cycle, then we'll apply some other operations. We'll change our algorithm of traversing in my linked list, and we'll do some other things if we know that if there is a cycle in my linked list or not. So how we can tell, how we can avoid this problem, to how we can remove the cycle in my linked list, or basically how we can detect a cycle in my linked list. To detect a cycle in my linked list, we use algorithm that is Floyd's cycle detection algorithm. So by using this algorithm, we can tell that in this particular linked list there is a cycle or not. So this algorithm will return either true. If there is a cycle, it will return true, or else it will return false. So by using this algorithm, we can detect if there is a cycle or not. Now let us talk about how this algorithm works. So let me clear my screen here. Stands Floyd's cycle detection algorithm. To understand Floyd's cycle detection algorithm, let us take a looped linked list 1, 2, 3, 4, 5, and it is pointing to this, and it is pointing to this, and it is pointing to this and this. So this is a cycle in my algorithm, cycle in my linked list. So Floyd cycle detection algorithm works on 2 pointers approach. So the approach will be, we use 2 pointers, that is slow and fast. We create 2 pointers in my linked list or in my function. After that, you need to understand one thing here, that slow will move by 1 step and fast will move by 2 steps, right? Initially this is my approach I'm talking about. This is the approach of my cycle detection. This is the approach. So what is the approach? First of all, we will create 2 pointers, slow and fast. Fast will move by 2 steps and slow will move by 1 step. Now initially I will point my slow is equals to fast is equals to my head. So initially my slow will be here and my fast will also be here, right? After that, I will start moving my fast and slow pointers. So at the first step, first of all, initially at the zeroth move, the distance between fast and slow. What is the distance between fast and slow? Fast comma slow is 0. So I will start moving my fast and slow pointers. So at the first step, at the first move, slow will come here, right? After that, the fast will come here, right? Slow will come here 1 step and fast will come 2 steps. So what is the distance between the fast and slow? You can see that the distance between fast and slow is 1. After that, the slow will come here and fast will come here 2 steps. So fast will come here. So what is the distance now? What is at the second move, at the second step, what is the distance between this is my slow now and this is my fast? So this is my fast. So what is the distance? 2. After that, the slow will come here and fast will move 2 steps. So fast will come here. So what is the distance? 1, 2, 3. So in my third move, what is the distance between fast and slow? 3. After that, slow will come here and fast will go here. So here you can see that 1, 2, 3, 4. So at the fourth move, what is the distance between fast and slow? 4. You can see that as the moves get increases, the distance as the move get increases, then the distance between fast and slow pointers will get also increases. So these increasing will get continued until if there is a loop in my linked list. Suppose if there is a loop in my linked list, let me clear all this thing first of all. Let me erase this. I am erasing all this step. Yep. Now let me come to my point. The logic here is after n moves, if there is a loop, if there is a cycle is true, if cycle is true, then after n moves, the distance between the slow and fast will become 0. It will become 0. If this becomes 0, then there is a cycle. If it is not equals to 0, the size is increasing, then there is no cycle. There is no cycle in my linked list. So after n moves, after like these pointer will move, this is my slow pointer, this is my fast pointer, it will move one step, it will move two steps. These moving will continue until the distance become my between the fast and 0, the distance becomes 0. So after n moves, these loop will continue, and fast and slow will meet at a place. At that point, the distance between the fast and the slow will become 0. At that point, if it is 0, then the cycle exists in my loop, in my linked list, or else it doesn't exist. As simple as that. So this is the main logic here. So you can observe one thing, that as moves are increasing, if there is, let us consider that if there is no cycle in my linked list, so as moves increases, the distance will also increases mathematically. If a pointer is moving by 1, then it will perform arithmetic operation, arithmetic progression. If the pointer is moving by 2, then it will grow, it will get like increased by 2 times. At each iteration it will get increased by 2 times, whereas slow pointer will get increased by only once, such that the distance between these slow and fast will get increased at each and every iteration, right? So if there is no cycle, then the distance between the fast and slow will also increase, and these step will continue until I hit my null. So if there is no cycle, then it must have a null. So these iteration will get continued until I hit my null. If there is a cycle, then after n moves, I will hit a case. I will definitely hit a case. At that particular case, my slow will become my fast, and slow minus fast will become 0. If this becomes 0, then there is a cycle in my linked list. So this logic is known as Floyd's cycle detection algorithm. I hope you got the point, and let us code this thing. Now here I am going to create my list, my function for cycle detection. For cycle detection, I am going to create public boolean type function. Boolean is a cycle. In this, first of all, I am going to create my slow variable, slow pointer, slow is equals to head. After that, my node fast is equals to head. So initially my slow will point to head, and my fast will also point to head. After that, I am going to run a loop while my fast is not equals to null and my fast dot next is not equals to null. In this, I am going to increment slow by 1. Slow is equals to slow dot next. After that, I am going to increment fast is equals to fast by 2 times. So fast dot next dot next. After that, if in any iteration, if my slow is equals to fast, then I am going to return true. Return true. Else return false. As simple as that. Now let me save, and here instead of creating my list, I am going to create my cycle linked list, a looped linked list which doesn't have any null. So ll dot head is equals to new node of, let me give 1 here. After that, ll dot head dot next, ll dot head dot next is equals to new node of, let me give 2 here. After that, here ll dot head dot next dot next is equals to new node of data 3. I'm trying to create a linked list as 1 is pointing to 2 and 2 is pointing to 3 and 3 is pointing to 4, 3 is pointing to 4 and 4 is pointing to 2. 4 is pointing to 2. So first of all I have created 1, 2, 3 and I need to create my 4 here. Head dot next dot next dot next. This next this looks a lot, but yeah, it is simple. You can also use function here, new node, and I am passing here 4. Now my node my 4 node will point to my 2. So here ll dot add here let me, instead of calling the function, I am using next. So next dot next dot next dot next is equals to, I am pointing to my second node. So here this node will point to this. So here I will point to this thing. That's all. This is how I'm gonna do this. Yeah. After that I'm calling my function system.out.print. I'm calling my function is cycle, and it is showing some kind of error. It is can't make static reference. Here I am making a function static. Yeah. Now let me save and run. So if I run this loop for my given linked list, ll dot cycle, and here let me remove static. Yeah. Now if I call my function is cycle, then this algorithm will give me true. Now let me save and run. So here you can see that this is giving me true. So this is the linked list I have created. So here 1 will point to 2 and 2 will point to 3 and 3 will point to 4 and 4 will point to again 2. So there is a cycle in my algorithm. So here this is how I can calculate my cycle in my algorithm. This is the working of Floyd cycle detection algorithm. Suppose if I am like commenting out this 171th line, comment down, and let me save and run here. So if I run here, then it will show me false because there is no loop. So if I comment down, remove the comment here, and now let me save and run, then there is a loop. So it will give me true. So this is how I am going to calculate how this is how I am going to detect if there is a loop in my cycle, if there is a loop in my linked list or not. Now let us talk about how we can remove if there is a loop. Then we know that it causes a lot of problem in traversing, in performing operations in my linked list. It causes a lot of problems. So how we can remove the cycle in my linked list? Let us talk about that. Now let us talk about how we can remove a cycle in my linked list. For that, let us take a cycle linked list 1, 2, 3, 4, 5, and it is pointing to this, and it is pointing to this one. Yeah, and it is pointing to this. So to remove a cycle in my linked list, I need to know two things. First, this is very simple now. So the first thing is, if I know the last node here, you can see that, let us say 1, 2, 3, 4, 5, 6, 7, 8. So if I know the last node, find last node. If I can able to find my last node, and the second step will be what I have to do, last node dot next. Last node dot next is pointing to 3. So instead of pointing to 3, if I point to null, then it will become my single linked list without any cycle. So what I am going to do, I have to just find the last node, and the second step will be last node dot next is equals to null. So if I can able to perform these two steps, then I can easily remove the cycle in my linked list. So the question is how we are going to find the last node. Let us talk about its approach. So the approach will be, first step will be, first of all we need to confirm that if there is a cycle in my linked list or not. If there is no cycle, then we don't need to like apply this function. If there is a cycle, then and only we can proceed. So the first step is detect cycle. Detect cycle. If the cycle is true, if it gives us true, then the first step will be I need to perform the operations. I need to perform an operation, that is I need to initialize slow is equals to head. After that, the second step will be I need to increment the slow by 1. After that, I need to increment fast by 1. So if I confirmed that the cycle exists in my linked list, then I need to perform these 2 steps. So as I iterate, I will hit a case here. So let us consider a scenario that this is my linked list 1, 2, 3, 4, 5, and it is pointing to this, it is pointing to this, it is pointing to this, and it is pointing to this. Okay, now we already know that to find a cycle we use 2 pointers approach, slow and fast, and we iterate slow by 1 and fast by 1. So after finding that a cycle exists in my, after confirming that a cycle exists in my given linked list, what I have to do, I need to change the value of slow. The first step will be change the value of slow. So slow will become my this value. Slow will become this. And before that, let us consider, let me remove this, I will explain you clearly. Let me remove this thing. Yeah, now let me choose my pen again. Yep, pen. Okay, now let us consider that at this particular location, my slow and fast becomes equal. That is, slow is equals to the distance between slow minus fast is equals to 0. So if the distance between slow and fast becomes 0, then there is a cycle. So I have find out the cycle. I have confirmed that a cycle exists in my given linked list. So after detecting the cycle, what I am going to do, I am going to change the value of slow. So the fast will remain here, but I am going to change the value of slow. So slow will become my head. After that, what I am going to do, I will run a loop, and I will increment slow by 1 and I will increment fast by 1. So after detecting a cycle, I will increment, I will change the value of head. This is this head value will become a slow. After that, I will increment slow. So slow will come here and fast will come here, and slow will come again. Slow will come here and fast will come here, and again slow will come here and fast will come here. After that, slow will come here and fast will come here. After that, slow will come here and fast will come here. So these process of iterating slow and fast will get continued mathematically until I hit a case, and that case is this case. So let us consider that this is my looping, this is my point of meeting, this is my point of cycle creation. Okay, so these head, slow and fast will iterate, will move throughout my cycle, and they will meet at a particular point, and mathematically that point will be this point. Mathematically you have to understand that this that if first step will be, the approach will be, I am detecting my cycle. If the cycle exists in my algorithm, then I will change the value of head. So slow will become head. After that, I will increment slow and I will increment fast. So the incrementation will continue until the slow and fast will meet at a point, and that point will be, mathematically that point will be the cycle creation point. You have to understand this. If you want to study more even about this, how we can mathematically derive this, then you can Google this. I'm not going into mathematical stuff, but yeah, the meeting of the slow and fast pointer after incrementing slow by 1, fast by 1 will be the cycle detection point, cycle creation point. The point will be this. So here, this is my linked list, right? 1, 3, 4, 5, and this, and it is pointing to this, and it is pointing to this. Okay, so after moving slow by 1 and fast by 1, they will meet at a particular point, and that point will be my cycle creation point. So they will meet at this point, conformly they will meet at this point. So if I can able to find, so the fast will be here, it will store some value, it will store this node, right? So this node dot previous will be my last node. So this is how I can able to find my last node. Now let us code this thing. So here I am creating my function remove cycle, public void remove cycle is my function. In this, first of all, I am going to detect a cycle. So how I can detect cycle in my function, cycle in my linked list? First of all, I am going to create a node slow is equals to head. After that, node, I need to give small o, node slow is equals to head. After that, node slow, node fast is equals to my head. After that, I am going to create a variable boolean cycle is cycle, boolean is cycle, yeah, boolean cycle is equals to false. So this variable will give me whether cycle exists or not. After that, I am running my loop while my fast is not equals to null, and my fast dot next is not equals to null. In this, what I am going to do, slow is equals to slow dot, I am going to increment slow by 1. I am just writing how we can detect the cycle in my linked list. Slow dot next. After that, I am incrementing fast by 2 times. So fast dot next. After that, if at any given point my fast is equals to slow, then boolean will become true, true. Okay, a cycle, right? Boolean cycle will become true, cycle is equals to true. After that, I am breaking my loop, break. If cycle is not there, then we don't need to remove cycle. So if cycle is equals to false, then return, and this is my out of the loop, return. This is out of my while loop. Yeah, I need to give statement terminator here. Now after finding that cycle exists, I need to find my meeting point. I told you, right, the slow and fast will meet after changing slow is equals to head, and after incrementing slow by 1 and fast by 1, they will meet at a point, and that point will be my cycle creation point. So I need to find the meeting point. For that, I am going to give slow is equals to head. After that, my node previous, I need to calculate the previous, right? So I need to give previous. I am creating a new node, previous is equals to initializing by null, while my slow is not equals to my fast. What I am going to do, I am going to store the value of previous is equals to fast. After that, slow is equals to slow dot next. After that, fast fast dot next. That's all. Now after running my old loop, I have stored the value of fast, I have stored the value of previous. So my previous dot next, I am changing the previous value, previous dot next is equals to null. That's all. This is how I am going to remove a cycle in my linked list. So first of all, let us see that whether cycle exists or not in my given linked list. So let me give here cycle and run. You can see that I have a cycle in my linked list. After that, I am calling system.out ll.remove cycle. I am calling remove cycle. After that, again I am printing after removing cycle, ll.remove cycle. I'm printing system.out.print ll. Is cycle. That's all. Now let me save and run. So initially cycle exists in my algorithm, and after removing the cycle I got my answer that there is no cycle in my algorithm, that is false. So this is how we can detect using Floyd cycle detection algorithm. We can detect whether the cycle exists in my linked list or not, and this is how we are going to remove the cycle in my given linked list. Now let us talk about a very important topic, at the same time very simple topic, that is Java collection framework. So in Java we have a JDK, that is Java collection framework. So in Java collection framework we have all the interfaces, all the inbuilt classes, and we don't need to create all our data structures from the like we have created linked list, right? We have given int data, node next. We don't have to do all those kind of things from the scratch. Java collection framework will give all the inbuilt, like a linked list, hash maps, array list, all those kind of things inbuilt, and we just have to write the syntax, and by just writing the syntax we can directly implement all the collections, all the functions, all the interfaces from my Java collection framework. So these are like inbuilt classes, interfaces, methods, data structures, and all those kind of things. And you may ask, right, why do we need we have studied all those kind of things, we have created our linked list, we have created operation for linked list. If we just know the syntax, and if we just know the Java collection framework, then directly we can import all the things, right? Why do we have to implement our linked list from the scratch? Yeah, that's a like valid argument there. But if the interviewer asks you to like build your own linked list from the scratch, then you have to know the concepts that how I can build my linked list from the scratch, right? You have to know those kind of things. For that reason I have told all the things. But in Java collection framework we have array list, we have vectors, we have stack, which we are going to study in the next chapter. We have studied about linked list, and we have in collections we have queue, in collections we have queue, and in queue we have priority queue, we have D queue, array queue, and all those kind of things. And we'll study all this in our next chapter. These all things are different chapters. And we have mapping, we have different sort of maps, hash map, tree map, and we'll talk about it in upcoming chapters. And we have tree set, hash set. These are very like important data structures, and when you are in competitive coding, you don't have to build your data structures from the scratch. You just have to know about Java collection framework, and you need to write your syntax, and by just writing your syntax you can directly import all the functions, all the data structures which are there in my Java collection framework. And these all the data structures we are having, these all the classes, interfaces we are having in Java collection framework. Now let us talk about how we can implement our linked list using our JCF, Java collection framework. Now to implement linked list using my Java collection framework, I need to import my linked list class. So for that I am going to write import java.util.linked list. That's all. By just doing this I can directly import all my linked list class into my program. Now let us code this thing and understand how we can import our linked list using my JCF. So for this I am creating my new file. Let me say jcf.java. That's all. I have created my file and JCF create file. So for that, first of all, first line I have to give here is I need to import I need to import my linked list class. So for that, linked list, or I can also directly import all the packages. To import all the whatever the packages we have in JCF, if I want to import all the things, then I need to write java.util.star. By doing this I can directly import all the things from my JCF. So for now I'm importing just linked list package. After that I need to write my boilerplate public class JCF. In this my main function public static void type function void main string args. In this, first of all, I need to create my linked list. So how I can create my linked list? I need to write linked list of. I need to specify what kind of linked list I am creating. Whether I am creating integer type linked list, whether I am creating boolean type linked list, whether I am creating like float type linked list. For now, I am creating integer type linked list. Integer ll is equals to new linked list. That's all. This is how I'm going to create my linked list. Now let us see how I can perform operations. In my linked list. So to perform operations, let us say that I want to add ll.add. I want to add 1. So I will just write, that's all. If I want to add first, so I need to write ll.add 2. After that ll.add 3. Suppose if I want to print my linked list, then I will just write here I need to give another braces. Yep, now it is good. System.out.print. If I want to print my ll, then I just have to write system.out.print ll. Now let me save and run. So here you can see that I got my linked list as 1, 2, 3. Suppose if I want to like remove the anything from my linked list, then I will just write remove 1. After that system.out.print and then after removing I am printing my linked list. Now let me save and run. So you can see that I have first of all inserted 1, 2, 3. After that at first index I have deleted my element. So this is how I can perform add operation, remove operation and all those kind of things, and we just have to write linked list. Instead of writing all this code, we can just directly import our Java linked list class from JCF, and we can perform all the operations. And when you are doing competitive coding, you have to do this. You don't have to implement your linked list from the scratch. So up to now we have talked about what is a linked list, operations on linked list, Floyd cycle detection algorithm, removing cycle, Java collection framework, and some questions.